Now we deep dive into 10x productivity. What does it mean and how can we achieve 10x? The safest and most efficient path to 10x is you start with moving to the cloud, but please don't reinvent wheels because this takes too long, is too error prone. Don't do it yourself, as we call it, but instead work with experts. You save time. Experts before made all these failures already, and you save a lot of money because doing it yourself might take a year, often enough, to set up a more complex architecture in the cloud, which ideally should be cloud agnostic. So it should run as is then on all providers. If you do one by one, you have to individually adopt and adjust to the underlying infrastructure. Usually, you start with a discovery meeting where everybody is around the table. On the user side, there are the engineers, there are the IT folks. Ideally, there is even a decision maker who can immediately say, no, I won't pay for that one. But yes, that is interesting, and this helps the company. A discovery meeting is really useful, and it ends with discussing a pilot or discussing a proof of concept. Right? Together, you develop the HPC cloud architecture for that, and you do this pilot or a proof of concept, depending on how fast you want to move finally to production. One of the solutions, as I promised, and now we are going deeper into the CAE application containers and the fully automated self-service engineering simulation platform. Let's start with the platform. The platform is basically a whole service stack, which then starts at the bottom with either the customer's cloud environment, if the customer has a private cloud. We have a few customers who do that, part of them even extremely powerful. Then the public cloud is the hyperscalers, AWS, Azure, Google, Oracle, IBM. Then we have on top, we have the management layer, management and service layer, which is in our example here, it is the UberCloud engineering simulation platform. On top of it, then, you have the application layer, and you are certainly very familiar with Ansys, Siemens, like Star CCM Plus, Abacus, Simulia does, I should say, and OpenFOAM. Numeka these days is Numeka, Cadence, Hexagon, MSC software, Altera, MATLAB, and so on. Now the pudding, right? The proof or the secret is in the pudding, which is the software containers. These containers are enhanced there is a microservice container layer underneath, but then we enhance this microservice container into macroservice containers for engineering simulation applications with simply adding all kinds of, in the order of 30, so to speak, HPC and engineering layers. The applications are pre-installed, configured, tested, and certified, and include HPC and CAE tools that are needed by engineers. For example, MPI, remote visualization, InfiniBand, RDMA, and many others. Remote desktops, I should not forget, which is very powerful and looks identical to what you are used to have on premise. As I said already, accessible through browser and login and password into this virtual desktop. You go through your browser, type in login and password, and then within a tenth of a second, you are in your application container. You upload your data, and then you are ready to set up a cluster with 7 clicks, any cluster you like, with any instances you need, that make good sense for your application, and then you can submit your job and run. The look and feel is really, as I already mentioned, this is the Azure Cloud look and feel here, and this is the on-premise look and feel on your workstation, for example, that you are used to work with for many years already. And engineers have told us, please don't change anything. We want to have the same look and feel and no learning needed at our fingertips. That's how we implement it then. About security, very quickly, these are the standard security layers that a cloud provider offers. But UberCloud adds 2 more layers of security to that. The top one is a secure container access via login and password. And the user is the only one who owns the login and password information. It's like a rental car. You get the key, and then the rental car is yours for the time you are driving it, and you pay for it, and then you don't need it anymore, you give it back. Then you get out of your container. On the other hand, the other green one is everything, and this is really very strong benefit. Everything runs in your own tenant, in your cloud account. And meaning you can create a cluster, and this cluster is single tenant. It is yours. Nobody can look over your shoulder what you're doing. Unlike quite a few other offerings in the market, where you go to the providers, like to the software providers or to the cloud providers, like a portal, like Cloud Portal or Cloud Appliance, which is controlled then by the cloud service provider who owns that portal. Right? With this approach, you can benefit from the hyperscalers discounts for your company, for example, but also you are the only one who has exclusive access and use of your environment. Even more deep dive, on the left side, there are sitting users, and this is a reference architecture that we have presented to one of our customers, FL Smith, the market leader for cement and mining machineries in Copenhagen. They are already UberCloud customers now for almost 5 years. And we have enhanced it recently with multi-region. This one is India, but also Australia, US, Brazil, and so on. This architecture is really extendable, and everything what you use in one region, you can easily then use and move to the other region and have your own architecture there. But you also can share the architecture with the headquarters and with the other regions. This left and right is simply the access part. And here in the middle, you have the real cloud part. Batch cluster, then on-demand, project cluster, on-demand visualization. This one here is specifically an example for Azure. You see the Cycle Cloud resource orchestrator to set up all that with a few clicks, and everything is connected through this architecture. And you see already here numbers 1, 2, 3, 4, 5, 6, 7, etc. What we have done in addition with this architecture, all the components, we have done a bill of materials. We have looked at all the individual components, put them together under services, type, quantity, and the size. And all together then, you can go either to the cloud provider's pricing page. Very often you don't find prices for all of that, so you have to dig into the internet. That's what we did. One of our engineers was so nice and took some time to put all that stuff together. Here's the table again with services, type, quantity, size, and he found out the cost. Some of the cost is per month. So we did a calculation for 100 jobs per month. That's what for a power user, this is not really seldom. And then we calculate per job. And what would you guess? A CFD analysis, fluid dynamics with 100 million cells, hexamesh. And I can disclose that this is star CCM Plus, and which runs 30 hours on a very powerful workstation, basically the most expensive one. And then when you put it on 16 nodes, 1,920 cores, it runs 1.5 hours. So it not only that this is about 15 times faster, but guess what it costs? Very often when I ask this question to friends, then they say about $1,000. Most of them even indeed answer 1,000. But it costs $122 for 1.5 hours on 16 nodes with 1920 cores. And whenever an engineer has a great idea for an innovation, for a great modification in the geometry, or for putting some additional physics into the whole thing, and this innovation just costs $122 and takes 1.5 hours. I still, whenever I see that slide, I find this amazing. An innovation costs $122. How much was it 20 years ago? Not everything is really beautiful or top easy or straightforward. Yes, there are still challenges. And we hear very often, oh, cost in the cloud is 5 times more than on-premise. That was true 10 years ago. So for some reason, some people tend to repeat this, but in the meantime, you get a lot more savings. And we get to that slide. We have, towards the end, we have a slide how you can really save a ton of money. And you need detailed usage, cost monitoring, and reporting. So if you just run your job without and then go home, and that's it, over the weekend, for example, then you pay for the resources. Even if your job is running only for 1 hour, you rent a car, you use it for 1 hour, and then you give it back next Monday. You pay for the car. That's very natural. Give the car back as soon as you are done. Same here. Give the resources back. Shut your cluster down as soon as you are done. The next two ones are continuously optimize and adjust your cloud architecture according to the latest technology changes. Cloud providers change and renew their hardware and middleware components it's almost DevOps, right? At least every 3-6 months or so, which you cannot do on premise. You cannot buy a supercomputer and then can exchange it after 3 months. You have to have it for 5 years. When I hear the argument that with a cloud provider, when you work with a cloud provider, this is cloud lock-in. We have some ideas how to avoid this. Right? But when you buy a 5 years a supercomputer from company X, from one of these large companies, and then you stick with this specific supercomputer architecture technology for 5 years. Hey, this is cloud this is on-premise lock-in. This is HPC lock-in. Right? You cannot easily exchange it because of, for example, you have 5 different applications, and they have to run all on that one supercomputer instead of 5 supercomputers, one for each of them in the cloud. Next one is strategic balance, the use of on-demand, reserved, and spot instances. With reserved, you save about maybe 20-30% of the cost. With a spot, you can save up to 80% or 75-80%, yeah, up to, compared to just list price. Very often in calculations, cloud calculations, that people just work with, obviously, this is the list price. And you can reduce it by a factor of 3, 4, 5 if you use the right instances. But you have to be careful because there are limitations that make sense. The next 3 ones are optimize not only compute, but also storage and data transfer. Data transfer is a real big thing these days. Many large companies have data lakes in the meantime, which are shared by different teams in different regions. And they all have to access the data lake and move data around to the different resources in the different regions and so on. With containers, obviously, running in the cloud, you can take the containers and run also on premise with it. For some very good reasons, you might have to take some of the simulations back to on-premise to your private cloud, then just take the whole container with your whole complex workflow and then move it back to on-premise. Fallback, that's similar. Uber Cloud, we can tackle that together. Now, finally, and that's the last part of my presentation, this is the benefits of the simulation platform plus the containers, plus sitting on the hyperscaler cloud infrastructure providers. Now, this is the slide I promised. This is about cost savings. And I already mentioned number 1, spot instances, reserved and spot. You can save between, I don't exaggerate, Wolfgang, maybe 20 to 70%. In some cases, there are these exceptions, but on average, the CAE licenses, you're faster if your job is faster in the cloud, then instead of 2 hours on premise where the job needs a license, then in the cloud it runs 1 hour. You get your license back faster by a factor of 2. So you can do twice as much with your license in the cloud when you have an on-premise and kind of a mid-size 1, 2, 3, 4, 5 years old PC system, then definitely you can save license cost, meaning you can use your licenses much more efficiently. Or 2 engineers can use the same license for 1 hour now in the cloud. Yeah. Either way, then 20 to 50% cost savings is when you closely monitor, analyze, and optimize your tools. You can save another 20 to 50% of the cost. Especially monitoring is very important so that you closely follow your execution of the job and you know exactly now it's done, you get a message, and then you shut down the cluster. Right? With more productive engineers. 1 engineer on premise, for example, needs 10 hours for 10 simulations, while in the cloud, she needs 1 hour on 10 servers. You use 10 servers in parallel, 10 simulations, just 1 hour. More accurate simulations allow discover failures in your next generation products earlier. This is really about discovery failures much earlier in your design and development process, and not just finally in the market when the product is already in the market. Right? You can save millions with that. Right? Cloud OpEx replaces most of on-prem CapEx. So you don't have to buy big machines for your on-premise use anymore with paying upfront big money, and then you have it for 5 years. In short, almost a mathematical formula, more resources mean more simulations, mean more parameters, whatever, materials or temperatures, pressures, whatever. And then better results, higher quality products. You can, for higher quality products, your company can charge more money. And finally, it can outcompete your competitors. So that's kind of a summary already. Some additional benefits, and then we are done. We have benefits put together for engineers for the three major constituencies in a company, like in, for example, a manufacturer. So you have the engineers and their managers, then you have the IT people who have to take care of bringing the right resources to the engineers, and providing all the bells and whistles around it. Today's on-premise infrastructures are highly complex, and still HPC is a silo. It's not easily integratable into the more standards-based enterprise infrastructure. With engineers and the managers and the IT people, and then the decision makers, the vice presidents and the CEO who are taking care of the company's benefit. For engineers, it's the cloud process is fully automated when you use the infrastructure and the containers that I discussed previously. Then the conversion of on-premise to HPC as a service. So everything what you do in the cloud, and again, it could be really a cloud also on-premise. It's HPC as a service, meaning you pay for what you use. Then greatest flexibility in the use of resources. This is mainly in the cloud, right? In the public cloud, sorry. And then you have this 10x for the engineer. An engineer can be 10x more productive. And we have so one of our largest customers in Silicon Valley, they have even, so their engineering simulation manager, we quote, says that some of his engineers achieve a 42x productivity, simply because they use a software which is developed for GPUs, right? And these GPUs are running 40, 50, or the job is running 40, 50, 60 times faster on GPUs. And that means that's in this case, 42x productivity boost. And you have always access to the latest hardware and software if you're an engineer, which is nice. You know, engineers, they always want the greatest and latest and best for very good reasons, because they want to make real progress for the benefit of their company. That's when they start to having fun. Right? It's very user-friendly for the engineers. It's cloud with one click, no learning needed. You basically move your application in a container to the cloud, or you move it from your cloud container repository onto your cluster, whichever you click set up, and that's it. Secure access, which I mentioned already, and containers contain engineering workflows. And there is also a virtual desktop in each container, which the engineer accesses so that the engineers have the same look and feel on premise and in the cloud. And remote visualization, that's high definition. It's GPU accelerated. It's high definition, frames per second. Each frame, 6 million pixels. And we haven't seen any jitter, even with 50 million or 100 million finite elements, for example. Maybe beyond that, obviously, yes, it's all a matter of latency. Corporate IT saves time by avoiding unforeseeable efforts due to do-it-yourself. Do-it-yourself is always an experiment. You never know how it will end. And there are analysts in our community who have analyzed this and found a very high failure rate with do-it-yourself. And I need to dig into that. But the last time I saw that, it was a 70% rate. Provide tools to corporate IT for managing, monitoring, health checking, maintaining, operating, and supporting. We provide the tools. So the IT people, they don't lose their jobs, but they get cloud tools at hand that help them to do their job in a very elegant way with all the tools they need. And also very often IT is interacting with our engineering team to continuously update and improve the cloud services. And few teams have few IT teams, I should say. Very rarely they have people who have this combined cloud, HPC, CAE, IT experience, which the engineers of our dev and DevOps teams have, who do it for up to 10 years now. Cost savings for based on monitoring, etc. These tools, which I already mentioned. So finally, CXO benefits in strategic terms, shortening time to market, increase product quality, and therefore strengthening competitiveness and the ability to innovate fast, as I mentioned. A ton of cost savings when you do it right, and also the integrability of a cloud service. It's much easier than integrating an HPC silo on-premise. So there's no cloud login because of containerization, and our platform sits on Kubernetes. Kubernetes, I should say, resource orchestration, managed Kubernetes.